So let's say I have the same account as before offered to me. I could put money into an account and I could earn 6% on it. So I'm going to analyze the present value of 2,500, given that if I had 2,000 euros right now, I could put it in an account. So a manipulation of this formula that we have come across before for future values, to get P, your principal amount or your present value amount, would be to get P on its own, I would divide both sides by 1 plus I to the power of T, and I would get this. And this, of course, is in your log tables here, present value on page 30. So a future value of 2,500 with an option of putting it in account to earn 6% for 7 years would give me a present value of 1,662.64. So it's quite clear that taking 2,000 euros now, I'd be better off. Of course, another way that you could analyze this deal would be to take the 2,000 euros and consider what the future value of that would be in 7 years' time. So I would use my future values formula then. And again, thinking that I could put it in that account, earn 6% over 7 years, I would get a future value of 3,007 euros and 26 cents. So yes, it is clearly better to take the 2,000 euros now. Okay, so now we're going to look at questions involving a series of present values and what they look like. So present value questions are not about money that you're going to get in the future. It's more about money that you're getting now and having to maybe pay back in the future. So typically they're very much linked with loan questions, but they can also be involved with pension questions where we can calculate the sum of money needed to be invested now to guarantee a fixed pension payable over a number of years. Okay, so let's have a look at both loan questions and pension questions to get an idea of how these series of present values questions work. Okay, let's take a look at this question. It says, calculate the size of the monthly repayments needed for a car loan of 10,000 euros if the loan is to be repaid over a 5-year fixed term at an effective monthly rate of 0.72%. So we're getting the money for the car now, okay? So that 10,000 euros we're getting now, but we are going to pay money back over a 5-year period. Okay, we have monthly repayments over that 5-year period. And what we need to consider then is, well, if we're getting this money now, and I'm going to continue paying money over 5 years, what are the present values of all those repayments? If I was able to invest each of those repayment amounts in an account every month, effectively earning 0.72%, then what would that actually amount up to? So that has to equate to 10,000 because I am getting 10,000 euros now. So the payments I'm going to make in the future has to equate to this present value of 10,000 now. So that's what makes this a series of present values question. First thing you need to do, as always, is check your rates and check everything matches. So we do have a monthly repayment, we do have a monthly rate, so that matches. But the 5-year term, of course, that time frame doesn't match. So 5 years is going to be the same as 5 times 12, 60 months. So we're talking about 60 repayment amounts altogether. Now, it's got to equate to 10,000 euros. So whatever the amount is that I'm going to pay back each month, I want to know what the present values are on all those. So let's consider obviously the last one first, because we always do this in kind of reverse order. The last repayment that I make would be able to be in the account for 1 month, okay? So technically earning 0.72% in that month. So what's the present value of that? So using obviously your present value formula, okay, so the present value is equal to future value divided by 1 plus I to the power of t. Of course, I is in decimal form. So it is 1 plus divide by 100, 0.0072 to the power of 1. That last payment is only in for 1 month. So the present value of that is this. And then the second last payment is going to be 1 plus 0.0072 to the power of 2, plus all the way up to that very first repayment amount, which would have a present value of a over 1 plus 0.0072 to the power of 60. So what is the present value of all of these particular repayment amounts that I'm going to be able to make in the future? Because it needs to equate to the value of the money that I'm getting right now, 10,000 euros to pay for this car. So I'm going to use my geometric series formula again, where this time my A first term is A over, I'll just add these together, 1.0072, power of 1, which is just that, of course. The common ratio. Now, what's happening each time? Well, it's the denominator that is going up in increasing powers each time, all right? Which means that you're only multiplying on the denominator. So the common ratio then is going to be 1 over 1.0072, okay? And multiplying fractions, multiplying on the top, multiplying on the bottom, remember. So that's what's going to allow the denominator to go up in increasing powers if the common ratio is 1 over 1.0072. And the end, the number of terms here is 60. So now filling in your geometric series formula. I'm getting this. Now, obviously, I can't put the A in on the calculator, but what I'm going to do is I'm just going to pull that out. Okay. And pulling that out, you'd end up with 1 over 1.0072. And so you see, if you multiply in that A, you'd get it on top like that. So just whip it out. And you see now this is what I can put in on the calculator. All this number work I can put in on the calculator. Now it is very tedious, so we're going to have to be very careful, okay? But I can put it all in there. So I'm going to put the fraction button up first, and then I'm going to start with this bracket here, and then I'm going to put in this fraction. So 1 over 1.0072, and now I'm going to close this bracket here, and I'm going to open up another bracket, 1 minus, and I'm going to open up another bracket and put in the fraction 1 over 1.0072. 0.72. Close that bracket to the power of 60 and close that bracket there. Come down then on the bottom, I'm going to do 1 minus, open the bracket again, and I'm going to put in that other fraction on the bottom, 1 over 1.00, and close the bracket. And I'm getting 48.58125,211. So I'm getting that multiplied by A, and of course now to get A on its own, I'm going to divide both sides by the 48.58125211. Keep the whole thing, don't round too early in any calculation, wait till the very end. So 10,000 divided by that gives me 205.84. So that's the monthly repayment amount I'm going to make over the next 5-year term, that allows me to get a present value of 10,000 now. So the series of present values I need to consider is what the 205.84 is worth to me, when I'm able to make that repayment over 5 years. Now, there is a formula I can use for to represent like mortgages and loans and things that require these series of present value type questions. And it's this, because a lot of the questions, as you'll see with that question, is telling you what the present value is now. You're getting the mortgage for a certain amount or the loan for a certain amount. In the previous example, of course, it was 10,000 euros for the car. And what you're asked to work out is what the actual repayment amount is, okay, for that present value of 10,000 euros, what you're getting right now. So this basically is a manipulation of what we have just done. It's a manipulation of considering all of your present values, and then working out what that repayment amount is. So again, it's just a manipulation of that. So I'm going to show you how we're going to get the very same answer doing this now, and then I'm going to show you how we get to this from what we originally did, okay? So there we go. There's our formula from page 31 of the log tables, and this gives me the repayment amount that I'm looking for. The principal value, of course, is the present value, what I'm getting right now, which is 10,000 euros. And then I have the interest rate in decimal, of course. We already figured out it was 0.002. And then 1 plus 0.0072 to the power of 60, of course, over 1 plus 0.0072 to the power of 60, take away 1. So I'm going to put all that in. That P basically is just outside, being multiplied in to all of that. All right, so I'm going to do that on my calculator. Open up my brackets. 0.0072. 1 plus 0.0072 to the power of 60. On the bottom then, 1 plus 0.0072 to the power of 60 again. Take away 1, and I'm just going to close those brackets, equals, and there we go. So how do we get to this? Now, the reason I am going to go into detail as to show you how we get to this is because it has come up in the past where you have been asked to derive this loan formula, okay? So I'm going to go through that quickly with you. So in general, this is what we have. We've got our principal amount. This is what we had as 10,000 euros equals, we didn't know the repayment amount, so we put it in as A. And then, of course, you put in your interest rate, whatever that is, starting off with the power of 1, 2, and then up to whatever or however many repayments you're going to make in that time frame. So we had, of course, 60 in the last example. So this is in general what we have. So basically, what you have in your log tables is a manipulation of this. The first thing I'm going to do, of course, is apply my sum of a geometric series formula. So again, your first term is going to be that, your common ratio. Remember the way we worked it out, it's the denominator that's going up in increasing powers. So it'll be 1 over the 1 plus I is what you're going to multiply by each time, your common ratio. Your N is whatever your value is there. Your T, however many repayments you have in the time frame. And so put it in the formula. And I get this. Now, we need to go from that to basically that, okay? So there's quite a little bit of manipulation I need to do. But if this question comes up and you're really quite unsure of the rest of the manipulation, the good news is you're going to get a lot of marks just getting to listing that out, to using your formula, to getting to there, okay? So that's quite straightforward. Okay, so I'm going to break down very slowly for you what I'm going to do here in each step of this manipulation. And the first thing I'm going to do is I'm going to get rid of this denominator 1 plus I. Right? And how you get rid of a denominator is you would always multiply. This is a fraction. So as long as I do the same thing to the top and the bottom of the fraction, I'm not going to change the value of the fraction. So this, because this has been multiplied to all of this, this is now kind of one term, okay? It's attached, so it's all together, okay? So if I multiply the top by 1 plus I, and the bottom terms by 1 plus I only need to multiply 1 plus I in once because this is all together, okay? But on the bottom, I'll multiply to everything on the bottom, so I'll multiply to this and this. So this is what I'm doing here, multiplying by the 1 plus I. And then that cancels with that, and that will also get rid of that denominator over there as well. Now let's just simplify what I'm left with. And the other thing I'm going to do is when you have a fraction to a power, right, if you remember from your laws of indices, then that's the same as the top to the power and the bottom to the power. So 1 to the power of t, no matter what t is, any power of 1 is still going to be 1. So I end up with a, that's now gone, 1 minus 1 to the power of t is 1, and the denominator to the power of t is 1 plus I to the power of t. So there we go. So I've kind of tidied that up quite nicely for myself there. Okay. And on the bottom, I have 1 plus I times 1, which is 1 plus I. And I have minus 1 because this is cancelled. And of course, 1 take away 1 is 0. That cancels as well. So this is what I have now. Okay. Okay, so now what I'm going to do, I'm going to pull this a out so I can see just what I'm left with here. I've got a 1 minus 1 over 1 plus I to the power of t all over I, okay? Right, so I want to just tidy this up now, okay? So the first thing I'm going to do is I'm going to get rid of this denominator here now, okay? I've got a 1 plus I all to the power of t. So how I'm going to get rid of that is I'm going to multiply top and bottom of this fraction by that 1 plus I to the power of t. And this is what I get. That allows that to cancel. And now I have a times 1 times that is, of course, that 1 plus I to the power of t. Only minus 1, that's gone. So only minus 1 on that side over I times 1 plus I to the power of t. Okay, super. So I am very nearly there now. This is what I'm looking to get, remember? So what I'm going to do now is I need to get a on its own. And the first thing I'm going to do to get a on its own, I'll get rid of this denominator, right? But I'm going to, rather than just consider manipulating the fraction that I have on the right-hand side, I'm now considering the full equation that I have here. And I'm going to multiply both sides of the equation by that denominator. And that cancels with that. I'm just going to move the p over to the other side now because that's the way it is in the log tables. And this is what I'm left with. And now to get a on its own, I'm going to get rid of all of this. So to get rid of all this, I'm going to divide both sides by it. That cancels with that. And of course, it leaves me with this, which is what I have here, basically. So that little formula in your log tables is a manipulation of the sum of a present values series. Okay, let's jump back into another question then. Here we're being asked to find the monthly repayments required for a mortgage of 150,000 based on an annual rate of 4.5% over 20 years. All right, so as always, we need to check, do our rates match? So we have monthly repayments, but an annual rate and an annual time frame. So none of that matches. We're going to have to tweak everything. So To change to get a monthly rate, remember it's 1 plus r to the power of 12 has got to equal the 1 plus I, and that of course is going to be equal to 1 plus the decimal form of 4.5 is 0.045 divided by 100. And of course now let's get the 12th root of that and then subtract 1. So the monthly rate, and we're getting 0.00367. And that's enough decimal places to use. You don't want to round obviously too early here. Now we have to look at the time frame, 20 years, of course. If we're talking about monthly repayments, 20 years is, of course, 240 months. So let's use our formula. So this is what I have in the log tables. So the repayment amount for a present principal amount of 150,000 is going to be and again, we'll put it in a calculator and just be careful. So I'm going to put in, it doesn't matter whether you put the 150,000 in front of the fraction or on the top of the fraction, because of course, when you're multiplying by fractions, you're multiplying a whole number in along the top. So I'll put it to the side where it is in the log tables, 150,000, then I'll open my brackets and put in my fractions. So I have 0.00367, and then I have 1 plus 0.00367 to the power of 240, and underneath I have 1 plus 0.00367 to the power of 240, subtract 1, and then close all those brackets, and I'm getting 941 and 22 cents. Okay, let's have a look at this question. And pause if you feel confident to have a go at this one on your own. Malcolm needs 400 euros per month for 3 years while he studies at college. What amount of money do his parents need to invest at 6.6% per annum, compounded monthly, to provide the money that Malcolm needs? Now, again, first thing we need to do is check the rate. We have a 6.6. PA means per annum, but it's compounded monthly, which means those rates don't match. So straight away, I'm going to do 1 plus r to the power of 12 is equal to 1 plus the decimal form of 6.6, which is 0.066. So that's, of course, going to be the 12th root of 1.066, and then subtract 1, giving me a monthly rate then of 0.005340. Okay. Now the time frame then is 3 years. We need that in months as well. So 3 years is, of course, 3 times 12, 36 months. So using our formula, we need 400 euros a month. So that's kind of the monthly amount we need. But I just don't know what the principal amount is. That money that we need to be able to have, that will allow us to take 400 a month for Malcolm. Okay, so subbing in everything into the formula. Okay, so we have everything filled in there now. So I'm going to work out, obviously I can't put P in the calculator, but I'll put everything else into the calculator then. I'm getting this. Again, don't round. You have plenty of decimal places when you write this down for accuracy. And now to get P on its own, I'm going to divide both sides by this. So 400 divided by that answer, and I'm getting 13068.84. So that's how much money they need up front to have ready for Malcolm to be able to take 400 euros per month over the next 3 years while he studies at college. Okay, so just a quick little recap then. With financial maths, there's a couple of things from your question that you need to be clear about. And the first thing always is, do the rates match? And by that, I mean the rates, how often you're paying something in, whether it's a loan or a savings installment, whatever it is. What's the frequency of that? Is it an annual rate, an annual installment, or is it an annual rate and monthly installment? And again, the time frame. Are we talking about this all happening over a 5-year term or what? All of those have to match. So the rate, if it's an annual rate, that means the installment frequency has to be annual and the time frame has to be in years. If not, you have to change things. If it's in terms of months, you're paying something in monthly, then you need the time frame in months. So you might need to change that, and you'll need the monthly rate. So you might need to change that. And then the second thing that you need to get clear in your head is this a question about a series of future values or a series of present values? So future values is all about usually savings and building something to have an amount in the future, okay? Present values is to do with being able to have an amount that you're then going to repay or draw money down from over a time frame that's beyond when you're getting the principal amount. So be clear about whether it's a series of future values or present values. And if you're unsure, do both, okay? You don't get penalized for choice in paper. So if you're a little bit unsure and you have time, do it both ways.